Okay, so welcome to part 2 on my introduction to the Quansheng UV-K5 and I'm going to be talking a little bit about the signals intelligence and listening capabilities of this radio here. Now the first thing you're going to want to do if you want to get into this is you're going to want to upgrade it to the EG Zoomer firmware. And that's how you spell it right there. And if you just Google that, you will find his GitHub page where he has this project. So what he did was he took the original radio. The chip inside had a lot more capability than the factory programming was taking advantage of, and he figured out he could do some really cool stuff with it. And he released an open source firmware update that you can just update this radio and unlock all of that capability and a couple of other cool features that I showed in the first video. What you'll need to do for that is you'll need to get your old Baofeng programming cable, the same $10 programming cable you probably already have, get it plugged into your computer and get the drivers installed, and then go to his website, and it's literally just click a button on his website and select the right COM port from the web browser. That's really slick. I would still download Chirp and use that to program the frequencies and channels in your radio, and I might be able to do a video on that some other time. But once you get that upgrade done, it does quite a bit for you. So let's get started. The most important update with that software is the Spectrum Analyzer function. Now what the Spectrum Analyzer function is going to do is it's going to listen to a very wide range of frequencies and plot them on a graph, how strong of a signal I'm receiving. So to unlock the Spectrum Analyzer, I'm going to press F and then 5. And it's going to start at whatever frequency that was active, right? So right now I have FRS5 is my active frequency. So when I hit F5, that frequency there, 462.6625, is going to be on the left side of my graph. Well, looks like it's actually in the middle. That's interesting. So here we see the Spectrum Analyzer is chugging along, and each one of these little spikes is a different radio signal that I might be able to listen to. I might not be able to make sense of every one of these signals. Some of them are going to be digital modes, and we'll get into what those sound like in a little bit. But it's plotting all of the activity going on in my area. So going around on the screen here, this 64X right here shows the number of bars that it's plotting, right? So there's 64 individual little bars that it's plotting. This 25K is how wide of a frequency range each of those bars is covering, right? And the combination of those two is going to tell you how wide your graph is overall, right? I'm going from 461.8625 all the way to 463.4625. If I add more bins, if I change that 64 to like 128, I'm going to cover twice the distance. Or if I increase or decrease the width of those individual bars, I will listen to a wider or narrower chunk, right? So like plotting it out visually, say I want to listen to 141 megahertz to 142 megahertz, I can have a relatively small number of bars or bins on my little chart here, and it'll scan faster, but I get a less detailed view of what's going on there. And if I have a signal show up, like right here maybe, it's going to show up in this bin, and it's going to give me the center frequency of this bin. That's all the more precise it knows. So I might be a little bit off frequency. I might have to tune a little bit, but I might still detect the signal. It'll just be less sensitive. If I want to get more specific into that same 141 to 142 megahertz, right, I could increase my number of bins, and I'll get a much more detailed view, and I'll see much more, fine-grained signals, and each one of them will be much more specific as to where that exact frequency is. I'll be probably closer to dead on in tuning, but this is going to take 3 times as long per sweep as this. So you're adjusting the number of bins and the width of those bins to compromise between how much of the radio spectrum you want to listen to versus how fast you want that scan to be. This radio will let you program a really, really, really wide chunk in with very, very narrow scans, but it might take you, 8 to 10 seconds to go from left to right for that screen to refresh. You see how it takes a little bit for the screen to refresh? Well, the slower that refresh rate is, the more likely you are to miss a short signal, right? So let's keep going. This little arrow here is whichever signal is highest on the display at the moment. Oh, look, that's a digital signal. And that one got above our squelch line. We'll talk about that in a bit. So I didn't understand that, but I could tell it was a radio signal. That's a digital signal. We'll get into that in a bit. So this little arrow is telling me the strongest signal I currently have and telling me the frequency of it. This is the leftmost edge of my graph and the rightmost edge of my graph. And if I hit the up and down arrow, I can scroll left or right. And then this is how much that scroll is. It's plus, right now, if I click the up, down, or up button or down button, it will move me 800 kilohertz to the left or right and looking at a different section of the spectrum, right? So this is whichever signal is strongest right now, indicated by the arrow. Over here is my demodulation method. So right now I'm listening in FM mode. I can also listen in AM mode or in upper sideband. And then this right here is the width of the signal that I'm listening to. So it's different from this. This is how wide the graph plot is for each individual group, each individual bin, right? But when I actually tune in on something, how wide is the bandwidth of the audio that's coming through the speaker? So this setting is the bandwidth for the audio coming through the speaker. So depending on where you're at in the spectrum and what the standard is for bandwidth, you might change that, but I wouldn't worry about this too much. If you listen to a signal with the wrong bandwidth, it'll sound a little bit distorted. It might be, a little bit kind of over-processed sounding, or it might be a little quieter than it ought to be, but it should be mostly intelligible, and you can just play with that to get it to sound better. So don't worry about that too much. But the FM side of that's very important. So the controls for the spectrum analyzer are extremely confusing because, he only had this keypad to start with, and he wasn't in charge of designing the keypad when he was programming it. So I made this little quick reference card to help me remember. So the up and down arrows will scroll your frequency, will scroll you left or right on the chart. The F5, so first F and then 5 is how you start the spectrum analyzer. You hit the exit button to get out. The push to talk, if you have a signal that you want to listen to, will pull up a little detailed view. So now I'm only listening to that one frequency I was at, so that little arrow is showing the strongest frequency is 462.1375. If I hit the push to talk, there's my 462.1375. And now I'm in the detailed view. So what's in here? This is my signal strength. And this is what makes this radio capable of radio direction finding. It's plotting how strong the signal is. So if I plug an antenna in and start waving it around, I can see when my signal gets stronger and when it gets weaker, and I can use that to get a bearing. This S right here is my S meter reading, which is kind of like a standardized signal strength reading that ham radio guys use. And then this is the number, right? So this is the dBm. So it's decibels relative to milliwatts that this signal is. It's a negative number, so the stronger the signal, the smaller this negative number gets. So if you can write that down at a given point, and then you can tell if your signal is getting stronger or weaker pretty well accurately, right? So the stronger the signal, further to the right, smaller these numbers get, the larger these numbers get, the weaker the signal, the further to the left, right? And then I can adjust. I have three different amplifiers that I can use to boost a weak signal. And then this is the intermediate frequency. Let's not worry about that. That's hardcore radio nerd stuff. So this line here is where my squelch is at. Any signal below that squelch level is not going to come through my speakers. Any signal stronger, and it's going to unlock my speakers and let me listen to it. And I can adjust that squelch on the keypad. I believe on the regular spectrum analyzer, it was star and F to adjust it up or down. Yep, there it is. All right, so now I can hear it. I move my squelch up, and I can't hear it anymore. Same thing out here. That dashed line all the way across is my squelch. So going back to my little quick reference here. Going back to my quick reference, the star and the F let me adjust my squelch. And the 0 changes between FM and AM. So that's AM modulation right there. And then upper sideband. For the most part, you'll leave it on FM. So yeah, what you're going to do is adjust your squelch to be just above the noise level, right? Let me turn the volume down. So that's the noise level at the bottom. Everything else is signal, right? So I'm going to adjust my squelch to be pretty low. And now let's say I know this signal is here. I don't really care about it. I don't want to listen to it. I can click the, what is it, S1, this little special button right here, and it'll ignore that exact signal. So I'm just going to ignore the signals I've already identified, right? So that's removing one or two of those bins from the area that I'm listening to, right? So I can ignore signals that are known. So if I have like a weather radio or whatever that's kicking off a signal that I don't care about, I can selectively click that button to ignore it. So what else do we have in here? So let's see. Yeah, 4 right here adjusts the number of bins. So right now I have 128. This is as most as it'll normally let you do. I can decrease it for 16. So this is going to be a lot faster of a scan. Here, let me turn my squelch up. Right, so a lot faster of a scan with 16, but less detail. 32, 64, 128. And you see at 128, it gets kind of laggy. Right, so it's a little less responsive. And then 1 and 7 are going to be adjusting the width of those individual scans. And as you play with the number of bins and the width of those bins, you can see your frequency spread that you're listening to is going to get greater or less, right? So I'm going to decrease the width. And this is going to get to be a less wide spread. So now I'm 461.8 to 463.4. Now I'm only at 463.1. Now I'm down to 462, right? As I get narrower in my bin, I'm listening to less of the spectrum. So let me bump that up again. Right? And then decrease. I think maybe 64 is about as many as I'd like to go. Otherwise it gets a little bit too laggy. What else do we have? So 2 and 8 adjust how much I move my graph to the left or right when I do up or down here. So right now it'll move 640 kilohertz. I can increase or decrease that so that my up or down arrow move me to the left or right. They take this whole graph and just shift it to the left or the right, so I'm listening to a different chunk there. I can adjust that step size with 2 or 8. And then I can use 5 to set the far left frequency. So let's do that real quick. So let's say, yeah, you know what? I'm going to save that for the little final exercise. So now 3 and 9 will adjust the scale of my graph here. So the top left here is showing the highest signal level on my graph, which is right now -50. And then I think the -146 is, I don't know if that's the average or the bottom. That's in dBm. So that's the strongest and weakest signal that'll be at the very top or the very bottom of this graph here. So I can adjust that. So most of my signals are at the bottom here. So I'm probably gonna adjust this down and kind of zoom in so I can see a little bit more detail here. So if all your signals are on the bottom of your graph, adjust your scaling so that you can see it a little bit more clearly, right? And then I can adjust, so 6 here adjusts my bandwidth for my receive. So on FM, it's either narrow, super narrow, or wide. right? So 25, 12.5 kilohertz or 6.25 kilohertz. You pretty much you can just leave it on 25. It's fine for receive bandwidth. 12.5 is actually more common, but 25 is fine. And then we already covered how to adjust my squelch on the left-hand side here. So on the back of this, I have, common frequency ranges that this guy can listen to. So the 17-meter ham band is 18.068 to 18.168. The airband for aircraft, 108 to 118 is VOR navigation beacons. And then 118 to 137 is the frequencies that the aircraft actually use. So let's tune this guy in for aircraft. So the far left, I'm going to want to be 118. So coming back over here, I'm going to input my low frequency. So I'm going to hit 5, and I'm going to do 118 point with the star, 0. And then to program that in, I hit menu. So now 118 is the far left. Now I want to go all the way up to, 137. Right now, it only goes up to 119. So I'm going to increase my number of bins, do a much slower scan. 120. And now I'm going to have to increase my bin size. And I might not be able to get the entire frequency in here. So the other thing I'm going to want to do is aircraft use AM instead of FM modulation. So I'm going to change that using the 0 key here. Switch it to AM. And now I might be able to
4.5 miles to the coast, but we're going to fix the left downwind to 180.
There we go. I picked up an aircraft. Something, something, something coming down on runway 18, right? So you can kind of see how this is supposed to work. You might have a hard time getting the entire wide range in one scan, right? 118 to 137 is pretty wide. So that's a lot to listen to at once. There's one other way to do this that I'm going to show you that's really handy. This is actually my preferred way to type in a frequency range, but you got to be careful because it'll let you type in a range that's so wide it takes forever to scan. So the way that I do that is I switch to frequency mode, and I have 118. So yeah, perfect. I did this before. I'm going to type in my lowest frequency on the top. I'm going to go to the bottom. Type in my highest frequency there, 137, right? I already did this, but 137.000, right? And now, set custom scan range, VFO-A to the bottom frequency, VFO-A to the top frequency, hold 5 to set the scan range, and now start my spectrum analyzer with F5. So now, it's going to go 118 to 137, and now look at the number of bins I have, 1900, because they're 10 kilohertz spacing. That's a lot. Look at how long it's taking to scan across that entire level, right? I'm going to have to get lucky to catch somebody talking. Oh, and I might have gotten lucky. Let's turn this down. Switch to AM. Maybe not. Right. But yeah, see how long it takes to scan. Yeah. That might be interference. I don't hear anything there, so I'm going to ignore that. Oh, sorry, wrong button. And it's going to keep scanning all the way across. Right. So if I want it to scan faster, I'm going to increase the size of the bins, right, with 1 and 7. And I'll say, I think they use 25 kilohertz spacing on AM. I don't remember. But now look how much faster it goes. Because instead of 1900, it's only 760. All right, ignore that frequency. Turn my squelch up a little. And I'll move my graph scale a little. There. So see how it's taken a long time to scan that width. But we've got a few signals already, and if you write down the frequencies they're at, you can gradually plot, what frequencies are commonly in use and what they're used for. So if you don't have access to, the internet where you can just look that stuff up. By the way, the website you'd use to look all this up is called Radio Reference. Yeah, that was pretty weak. I couldn't quite hear him. But if you go to radioreference.com, you can look up common frequencies in your area, but that's basically a whole nother video. All right, so I hope that helps. This is an extremely cool functionality for a $35 radio you can carry in your pocket and use for two-way communication. This is a very useful scanner. So yeah, you can use it on any of these frequency ranges. Public safety right there, business right there, satellite communications even. I've never tried to listen in on satellite communications. Most of them are probably digital. The 2-meter ham band, AIS, so that's marine automatic beacons that are communicating, position and navigation information for boats. Your marine band, ham bands, all sorts of fun stuff in there. So, well, I hope this was useful, and I will probably, I'll try and get another video out at some point covering some radio direction finding skills. The first step for radio direction finding is to find whatever signal you want to track. So this is how you would do that. And then you can use this detail mode right here with a nice directional antenna to actually try and get a bearing on that signal. So that would be the next step. All right, I'll catch you next time.